percentage of the parallelogram is shaded? Okay, so the answer is simple. Once this is the midpoint, so long as this is the E and F are the midpoint and the two are used in forming a triangle such that the opposite vertex of the vertex adjacent to the sides containing the midpoints. So once you form a triangle with these 3 points, that it's always the area of the triangle EFD is always 3/8 of the area of the parallelogram. Yes, I'll show you how. So since we are talking about percent, the whole parallelogram is 100%. So 3/8 times 100%. Yes, which is, that should be 37.5%. So that's option B. So let me now tell you how I arrive at that. So this parallelogram is the same parallelogram, yes. So let's, in the first diagram, so assuming this is the midpoint, E and F are always the midpoints. So meaning it divides this side into 2 equal parts. So if I've joined the vertices of that's the 2 opposite vertices. So once you see this triangle ABC, what comes to your mind is similar triangle, and there's a theorem under it called mid-segment theorem, which says that the segment joining the midpoints of 2 sides of a triangle will always be half the third side. Yes, so if here is x, here is x, and also is parallel to it. So if here is x, here is 2x. So by mid-segment theorem, yes. Now, since the length, I'm using similar triangle, that's ratio of area. So if you do ratio of area of triangle EBF to that of triangle, the bigger one, which is triangle ABC, the ratio of, if you could remember, ratio of similar triangle will always be ratio of the squares of the corresponding side, so which is now x squared over 2x all squared, so it will be 1:4. Yes, so by implication, if the area here, if the area is A, the remaining will be 3A, so that the total area will be 4A. That's the ratio of the will now be 1:4. So since here is 4A, here will also be 4A, yes, because if you divide the parallelogram into 2 equal parts, since the area of this one is 4A, this one is 4A, so that same thing here, the total area now, the total area will be 8A. Yes, since here is also the same as this, the same diagram, I just decided to join. In the second one, we now join the other 2 remaining vertices. Since we have the midpoint, so we know that the median, which is DE and DF of any triangle, this is also the same, is the midpoint. The median divides the triangle into 2 equal areas. Yes, since the total area here is 8A, so each of them will be 4A. So if here is 2A, here is 2A, here is 2A, here is 2A. Yes, since here is 4A now, the total is 8A. So we are done. So we can combine the 3 diagrams now. Yes, so if we combine the 3 diagrams, the last diagram now, so look at the final diagram. Yes, if we now, which is similar to the question they asked us. Remember, we've gotten here to be 2a and 2a. Look at it. So remaining 4a here. And since we've gotten here 2a, 2a. Also, we've gotten here as a, so let's go and put it a. So remember, the total area remaining should be 4a, as you can see. Once you've added 2a to a, this is 4a. Therefore, this should be 3a to make it 4a. Yes. So that's how I got that the area of the triangle formed by the two midpoints and the other vertex is always 3/8 because the total area is 8a. So it's always 3/8 of the total area. So that's why I said it should be 3/8. So that's it. Thank you.